Hi everyone, in this video I'm going to show you how to enable dynamic provisioning in on-prem Kubernetes cluster with AWS EBS CSI driver. Alright, so basically when you deploy a self-hosted Kubernetes cluster, that cluster doesn't come out of the box with any form of storage class. All right, so you have to determine what kind of storage class that you need to use, and the kind of storage class you are going to use depends on the kind of provisioning that you can use. All right, so I'm going to show you how to set this up. All right, so let's log into our AWS account and navigate to AWS Management Console, and I will walk you through all those steps. Alright guys, so I am already logged into my AWS console, and I will go to my AWS EC2 dashboard, and you can see that all my EC2 instances are stocked. Of course, now this is my Bastion host and my managed cluster. So what I'm going to do here is that I'm going to go ahead and turn this on. Okay, I want to restart all of this. All right, let me restart this and refresh that. The Bastion host is already running, so I'm going to go ahead and copy the public IP address of my Bastion host, navigate to my Visual Studio Code, and I'll go to this location, and then I'll change this IP address. Alright, save it, and then SSH to your Bastion host. Let me SSH to my Bastion host, continue, and I should be in my Bastion host. So I'm in my Bastion host, guys. So let me do ls, and I will do get node. Let me see if my nodes are up and running. Yes, you can see that my nodes are up and running. Okay, let me see what says my port. Right, my port are up and running, and one of my port is unknown. Yeah, so this port is in an unknown state because we actually don't have our NAT gateway created. So I'm going to go to my VPC dashboard and recreate my NAT gateway and attach it to my private route table. So let me go to my VPC dashboard, type VPC, click on VPC. So navigate to NAT gateways, and we are going to create a NAT gateway. In here, I'll type public dash NAT gateway, NAT WG, and I'll select my public subnet, this public subnet dash P1. Remember, you always have to create your NAT gateway in your public subnet, right? So I don't have any already allocated elastic IP address, so I'm going to go ahead and hit on allocate elastic IP address to create one. Then after that, I will hit on create NAT gateway. So this should create a NAT gateway, right? So click back on the NAT gateway. This should be in pending state. Now let's go back to our route tables. So this is the route table for my worker node, and I will hit on my cluster, for my cluster, because you can see that it has these two subnets, the control plane subnet and the data plane subnet. So I'm going to click on this, and in here, guys, you can see that the status of this route is in the black hole. What this means is that the previous NAT gateway that was attached to this got deleted because I told you in my previous video that you need to delete this NAT gateway. That way you shouldn't get any sort of charges while keeping that static IP address. Okay, so I'm gonna go do edit route. Then we are already in the NAT gateway field on that target. So I'm going to go and select my new NAT gateway that I just created, and I'll do save changes. All right, so let's head over back to our NAT gateways, refresh. So our NAT is not still yet available. Okay, so once this NAT is available, you will notice that this port is going to come back up because it is an unknown status because it's not able to communicate properly. So let me do that again. You can see that the port is in a crash loop back off. Now, there is one thing I want to point out here again. So whenever you deploy a Kubernetes cluster, right, that Kubernetes cluster doesn't come with any form of container network interface, which in other words is called CNI. Now, you can see that we already have Calico as our container network interface deployed, but you can see that most of these ports are not in any are not in the 1.1/1 status because they are not ready yet. Okay, even though they are running, but they are not ready yet. So we need to actually go back to our firewall and add a firewall rule that will enable our node to communicate within themselves. That way, this port can be in a one-on-one ready state. Okay, so we have to head back to our EC2 dashboard. Click on your master node. So go to security, and this should bring your security group up, right? So click on that security group and do edit inbound rule. So we are going to be adding a custom TCP 190.179 for that Calico network, okay, interface. Now we are going to select, so we are in our bastion host, not bastion host, but control plane security group. So we want to edit, we want to enable this route to our control plane, sorry, data plane. Okay, click on data plane. Another rule we need to add here is the SSH, not SSH, HTTPS firewall rule for our storage container storage interface. Okay, we are going to be attaching this. That way our EBS CSI driver will be able to make API calls to our EBS services on AWS. All right, so let's add our network side here. So let me do 172.31.0.0/1. Okay, let's add that and do save rules. Okay, now the next thing we need to do is to hop over back to our EC2 dashboard and select one of our worker node and do the same thing. All right, remember all our worker nodes use the same security group. So we are going to do edit inbound rules. So let's add a custom TCP of 179 for our Calico network interface. So we are going to select our control plane security group. So we'll be adding an HTTPS firewall rule for our EBS CSI driver, and that should have a destination of our network CIDR 3.1.0.0/20. Okay, so let's select this and hit on save rules. Now let's go back to our terminal and see if this Calico node port are actually in a one-on-one ready state. Okay, let's try again. Okay guys, so you can see that they are now up and running. Now, what is AWS EBS CSI driver? EBS CSI driver is actually a service that helps a Kubernetes administrator to request EBS volume to persist data. Okay, so this is done through what is known as a storage class. So we are going to install this driver and then set up some configuration. That way we can actually request EBS volume to persist our data. So to start, if I say k8s, because the alias of storage class is SC, okay, you should not see any storage class in our Kubernetes environment because we don't have one. Like I said earlier, when you deploy a self-hosted Kubernetes cluster, even a managed Kubernetes cluster, okay, most cloud providers don't kind of provide a storage class for you. You have to set up a storage class depending on how your application works and what kind of storage that you need. You may want to use an NFS, you may want to use EBS or even S3 bucket for that. Okay, so first thing first that we need to do is to actually create an IAM rule that will make that call, okay, and assign them to all our nodes. All right, so let's go back to our EC2 dashboard and create that IAM rule. Now, in my VPC dashboard, I'm going to type here IAM. So hit on IAM and then go to rules, then do create rule. So we are going to leave it under AWS services. Under use case, select EC2 and do next. So what we need to use here is EBS. Let's type EBS driver policy. Okay, let's hit on this one and do next. In here, type the name. So I'm going to call it EBS-driver. Let me say CSI driver. Okay, CSI driver. And I call it rule. So I'm going to copy this. Okay, in here, hit on create rule. So this should create this rule. And first thing first is to go back to our EC2 dashboard and assign those rules, that rule we created, to each of our Kubernetes node, right? So let's go to our master and do security modify rule. So let's paste that rule. This is already injected here. Let's go back here. Then security modify rule. Let's paste this. Save this. All right. Go back to the next node and action security modify rule. Paste this. All right. Select the rule. Update the next node, action security modify rule, select the rule name, and then let's save. All right, so now that complete the IAM assignment to our node. All right, now our node now have all the IAM rules that they need. So meaning that if we create a pod in our Kubernetes environment, these nodes are capable of attaching an EBS volume to themselves so that our application can then create a mount point and store data within those paths. Okay, so The next thing we need to do is to actually get the Kubernetes manifest for EBS CSI driver. Okay, so I'm going to show you how to get this. So we are going to use a Helm chart for this. All right, so do helm.sh, helm.sh, hit enter. So up here you should do chart, go to chart and do ebs-csi-driver. I'm going to type ebs-csi-driver. Okay, so I'm going to look for a global one. So I will go with this guy. And in here, you should see the installation. Click on the installation. And this is how you should copy this, go back to your terminal, and paste. Right. So I have already added this Helm repository to my local. And what you can do next is to grab the Helm chart. Okay. I always like to pull my Helm chart locally and use it. So let me do this. So I'll do plus, let me do this, ls. So I will do Helm search. If you don't have search, if you don't have Helm installed already, you can install Helm. That way you can run Helm command locally. And I'm going to show you how to install Helm. So go to documentation, go to how to, okay, and then go to introduction rather and do install Helm. So this should show you how to install Helm. So you can install Helm depending on your operating system. All right. So if you don't have Helm already installed, follow this documentation right here to install Helm on your local. Okay. Now let me search the repository that we just created. So before we do that, once you add your repository, the next thing you need to do is to update your local Helm repository. All right. So do Helm repo update. There's no dash y. Okay. So I'm going to do Helm search repo. This guy. So now this, I want to pull my Helm chart, cd pass and learn. So let me pull my Helm chart. Okay, Helm, pull this Helm chart for me, and let me untie it. Okay, let me show you. Let me even do it like this, and then I'll do this. You can see here that my Helm chart is like this. So I need to untie it to actually get the package. Okay, so let me remove that and I'll show you a short way to untie this on the fly. Okay, RAF AWS. Okay, so I'll call back that same command and I'll type untar. Right, let's untar that. So if you do ls, you should see our ebs-csi driver. Okay, now let me open my VS Code on my person learn directory here, and I will be closing the old one. So open this up. That way I should have access to my AWS EBS CSI driver Helm chart. So the chart is here. There is actually no modification that we need to do here. So let's go ahead and install our AWS EBS CSI driver. So to install that, you can either do Helm install AWS I'm going to be doing this in kube system namespace. Then I'll pass the directory, okay, my AWS CSI-driver directory. I'm going to hit enter. So this should install my driver for me. So if I do k namespace kube system get pod, you should see my pod coming up with my EBS CSI driver. You can see that they just came up like 12 seconds ago, right? Those are my pod right there. Now, all right, guys, so let's go ahead and see if we have our provisioner up and running. To do that, run k api-resources, hit enter. Okay, so here you should see our provisioner here. All right, let's copy this and do k bed and see what the name is. So the name is ebs-csi-driver.com. What this name, whatever this name is. All right, so if you do that and paste this and do -OYAML, this should give you a live manifest of this provisioner. All right, so now let's go ahead and deploy our storage class. Okay, and before we do that, I will open the storage class here. This is the Kubernetes manifest of the storage class, and we are defining the provisioner here. All right, and this provisioner is actually defined in the driver. All right, so we're defining it here, and we are making our storage class to be a default storage class. There is one thing here that I want to let you know, and it's very important. Okay, this reclaim policy. Here I'm setting it to delete because I don't really care about losing any data here, and this is just a demo environment. I don't want to keep EBS volume running and I have to pay for keeping that. Okay, so if you are doing this in sort of production environment, always make sure your claim policy is returned, except for any application that you don't really care about losing the data, because claim policy are two of them. All right, so you have return and delete. So I'm using delete like I said earlier because I don't care about this. So what this means is that when your claim policy is delete, it means that when you delete your pod and the persistent volume claim gets deleted, the next thing that gets deleted is the persistent volume, right? And the next thing is your EBS volume in your AWS account gets deleted as well. So if you have any important data that is already saved in there without any some sort of snapshot that was created on your EBS volume, you will lose that data. All right, so always make sure you set this policy you set this policy based on your own use case. All right, so let's go ahead and deploy this this storage class. So I'll navigate to my K8 folder, dynamic provisioning, and then resources. Okay, let's do k apply -f storage here, and then let's do k8s. So we should see that our storage class has been created and it has this reclaim policy. All right. The next thing we need to deploy is our pod. Okay, and before we do that, I need to open this pod and show you how it's being designed. So we're using this storage or a volume, and we're actually claiming a persistent volume claim. Okay, and the name of the persistent volume claim is this guy, and the persistent volume claim manifest is here. Okay, you can see that we are claiming a 10 GI of our storage, meaning that this will go ahead in our AWS and create an EBS volume with this storage that is requested. Okay. Now, what you need to know is that the name that you are passing on your persistent volume claim must match the name that you have on your pod. Okay. So I have this this configuration in this documentation. Let me show you as I learn. I have them here, and once you go here, you go to your dynamic provisioning, you should see that under resources. So I'll be putting the link of this Git repository in the video description. That way you can access this. All right. So in your own manifest, let's say this persistent volume, you may see this storage class which is manual. So make sure you remove this. Okay. Make sure you remove that and keep it like this, and keep it without any storage class fee under spec. All right. So let's navigate back to our Bastion host. And the next thing we need to do here is to deploy our persistent volume claim. So what I'm going to do is k apply-f and pvc. Let's hit enter and do k8pv. So we don't have a persistent volume now created, because if you go back to our storage class, you can see that the volume binding mode is wait for first consumer. All right. What this means is that we must delete a pod. We must deploy a pod before it can consume or request a persistent volume. Okay. So to do that, what I need to do first is to go to our AWS account, and on EC2 dashboard, go to volume section and refresh this. Okay, let's refresh this. You should see that we have actually 5 EBS volume, which are all root volume attached to our current servers. We don't have any extra volume here. Okay. So when we will create an application that will request a volume, you will come here and see that an additional EBS volume has been created and attached to your pod, and that will be done dynamically. Okay, you don't have to manually do that. All right. So let's go back and create our pod. So let's do k apply-f. So pod manifest is here. Let's check our pod and see what is happening. So you can see that our pod is in pending state. Let's try that again. Let's check PV. No PV yet. Pod is in pending state. So let's wait for a second, guys, and see what happens. All right. Before we do that, let me describe the pod and see what is happening. Okay, describe PO. Let me paste this guy. Okay. Let's do get PVC. Let's make sure our PVC is created. So that is T not creating an EBS volume. Let's wait for a second and see. Okay. So while waiting, what we can do is to check the logs of our CSI driver controller. Cube system get pod. Okay, let's check the logs of this guy. Logs. Let's press this. So let me do get part again. Let me copy this. Okay. Logs. And I hit this. So we can see that there are 5 containers in that pod. I'm going to do all containers. I don't know what container is doing what, but let's see. Okay. I don't see anything here, guys. Let me see this again. The PVC. Oh, okay. You can see that our PVC now is bound to this persistent volume, right? And it has a storage capacity of 10 GI, just the way we specified that here. Okay. Now it looks like you have to wait for a couple of minutes for this to get propagated. So let's head over back to our EC2 dashboard and go to the volume section. You can see that these are still our root volume, and what we need to do is to refresh this and see if additional volume has been added. Now you can see that this additional volume has been added. So you can see here, if you go back to our storage class, you can see that the parameter type here is GP2, okay? And if you come back to the dashboard, you can see that the type here is GP2 as well, okay? So that is how you enable dynamic provisioning in your Kubernetes cluster, okay? Now, there is one thing I need to show you again. Here is a stateful set manifest, and this stateful state manifest is designed in such a way that a volume template is actually embedded in it, okay? You don't actually have to create a separate persistent volume claim and assign it to this. You can just pass a volume template field to your stateful set and just set the storage that you need to request. Let me say I need a 50 here, and let's save this and apply it. So I'm going to show you something. So okay, apply -f stateful set. Okay, let me deploy that stateful set. So it's the stateful set, right? Okay, stateful set. Let me apply this, and let's do get pod again and see if we get a pod running here. So you can see that this pod are in pending state. So how about check for PVC and see if we already have PVC getting created. Now you can see that we have this PVC in pending status because it's making that request. To check if that request is getting successful or failing, you should check the logs of your EBS CSI controller. Okay, let me task and -f flag here to follow the logs. I don't really see any request that is making, but we can actually still check and see. Okay, 50 seconds rebuild. So I'm gonna wait for a minute. It looks like this takes a little bit of time to, yep, you can see that that has been created, so that takes a little bit of time. So let's do the PVC again. All right, then let's do a pod. Okay, you can see that this is getting created. Now, this stateful set has only 2 replicas, as you can see here. Okay, the stateful set called web has only 2 replicas. So I can boom this stateful set, and each time I boom it up, what will happen is that it will create extra persistent volume claim and persistent volume, and this persistent volume will actually make an API call to AWS EBS volume to create those volumes for us. All right, so let's do that. Let me boom this stateful set to about 5 replicas. So I'll do k8s and then I'll paste the name here, /replicas to be 5. Let me say 5. Let's check our pod again and see. So the second pod is, the third pod just started. Okay, this third pod just started. So what this has to do is that it needs to create this pod progressively. Okay, you can't see it until you have 4 pod here. So you start from 0, 1, 2, 3, 4. Okay, because we are asking for 5. So let me do PVC. Let's see what is getting created. Now you can see that we have our stateful set with 1, 2, 3, 0, 1, 2, 3, 4, right? Meaning that our pod should be up and running successfully. All right, so let me show you another thing. So how do you know what node has this EBS volume attached to? To do that, you can do get pod -o wired -o wired, clear this and hit enter. You can see that they are getting attached to all our worker node. So starting from here, you can see that this one is attached to node 1, node 2, node 3, node 1, node 2, right? So let's head over back to our AWS management console on the EC2 dashboard and refresh this. You can see this bunch of EBS volume attached to our node, and here you can see that they are all in use. Okay, they are all in use. All right, so this is how you enable dynamic provisioning in your on-prem or self-hosted Kubernetes cluster. I didn't have to do anything manually. Okay, I didn't have to create a persistent volume, create a persistent volume claim, and then create a pod. So you just need a persistent volume claim and your pod manifest. So you should be good to go. Now, let's go ahead and delete some of this, because you need to delete all of these things, because if you don't delete it and turn off your cluster, AWS will charge you for these extra volumes. What AWS doesn't charge you for are the root volumes, but if you keep this up, they are going to charge you for this additional volumes that you just created. So let me scale my stateful set down to 0. So that should scale it down to 0. If I do get pod again, you should see that my pod are getting deleted. Okay, they got deleted. So if I do get PVC, you should see all those PVC. So the first thing I need to do again here is to delete my -f. Let me do delete -f pod, and then I'll delete PVC. Okay, let's delete that PVC. Let's get pod. Okay, let me do PVC. All right, let me delete all of this PVC. Okay, delete PVC -o -false. That should clean up all those PVC for me. How about PV? You see, all the PV are gone. All right, now if you go back to your AWS management console and refresh, you should see that all those volumes are deleted. Why? Because on our claim policy on the storage class, we said delete them. If it was returned, AWS will return those volumes for us. Okay, so that's how you do this kind of setup. All right, so guys, I hope this helps you to set up dynamic provisioning in your self-hosted Kubernetes cluster on AWS. So please like this video, comment, leave your question on the comment section, and I'll be more than happy to answer it. All right. Thank you so much and have a wonderful rest of your time. Bye-bye.